60 facts about logarithms. Basic concepts. 1. Definition. A logarithm is the inverse function of exponentiation. If b caret y equals x, then y equals log underscore b, x. 2. Base. The base of a logarithm is the number raised to the power. In the example above, b is the base. 3. Common logarithm. A logarithm with base 10 is called a common logarithm and is often written as log x. 4. Natural logarithm. A logarithm with base e, Euler's number, is called a natural logarithm and is written as ln x. 5. Properties. Logarithms follow several properties, including log underscore b, 1, equals 0 log underscore b, b, equals 1 log underscore b, x caret y, equals y log underscore b, x, log underscore b, xy, equals log underscore b, x, plus log underscore b, y, log underscore b, x, y, equals log underscore b, x, log underscore b, y, log underscore b, x, equals log underscore a, x, log underscore a, b. Change of base formula. Historical significance. 6. Inventor. John Napier, a Scottish mathematician, is credited with inventing logarithms in the early 17th century. 7. Purpose. Logarithms were originally developed to simplify complex calculations, especially in astronomy and navigation. 8. Slide rule. The slide rule, a mechanical analog computing device, used logarithms to perform calculations quickly and efficiently. Applications. 9. Scientific notation. Logarithms are used to represent very large or very small numbers in scientific notation. 10. Chemistry. pH, a measure of acidity or alkalinity, is calculated using logarithms. 11. Physics. Decibels, dB, a unit of measurement for sound intensity, are based on logarithms. 12. Finance. Logarithmic scales are often used to represent financial data, such as stock prices or economic indicators. 13. Computer science. Logarithms are used in algorithms for sorting, searching, and solving various problems. 14. Statistics. Logarithmic transformations are sometimes used to normalize data or to model relationships between variables. 15. Mathematics. Logarithms are essential in many areas of mathematics, including calculus, number theory, and complex analysis. Advanced topics. 16. Complex logarithms. Logarithms of complex numbers can be defined, but they are multi-valued functions. 17. Hyperbolic functions. The hyperbolic functions, sine, cosh, tan, etc., can be defined using logarithms. 18. Riemann zeta function. A famous function in number theory, the Riemann zeta function, involves logarithms. 19. Fractal geometry. Logarithms are used in the study of fractals, which are self-similar geometric objects. 20. Information theory. The entropy of a probability distribution is measured using logarithms. Miscellaneous facts. 21. Logarithmic spirals. These are spirals that grow exponentially outward, with each successive turn being a constant ratio larger than the previous one. 22. Logarithmic graphs. Graphs with logarithmic scales on one or both axes are used to visualize data that grows or decays exponentially. 23. Logarithmic identities. There are many identities involving logarithms, such as log underscore b, x caret 1, y, equals 1, y, asterisk log underscore b, x. 24. Logarithmic differentiation. A technique used in calculus to differentiate functions that involve logarithms. 25. Logarithmic regression. A statistical method used to model relationships between variables when one or both variables are logarithmic. 26. Logarithmic scales on instruments. Many instruments, such as sound meters and seismographs, use logarithmic scales to measure quantities. 27. Logarithmic puzzles. There are various puzzles and brain teasers that involve logarithms. 28. Logarithmic identities in astronomy. Logarithmic identities are used in astronomy to calculate distances and magnitudes of celestial objects. 29. Logarithmic spiral galaxies. Some galaxies have a logarithmic spiral structure, similar to the shape of a logarithmic spiral. 30. Logarithmic scales in music. The decibel scale used to measure sound intensity is based on logarithms. 31. Logarithmic scales in biology. Logarithmic scales are used to study population growth and other biological processes. 32. Logarithmic scales in economics. Logarithmic scales are used to analyze economic data, such as GDP growth and inflation rates. 33. Logarithmic scales in geology. Logarithmic scales are used to measure earthquake magnitudes and other geological phenomena. 34. Logarithmic scales in chemistry. Logarithmic scales are used to measure pH, acidity, and alkalinity. 35. Logarithmic scales in physics. Logarithmic scales are used to measure sound intensity, light intensity, and other physical quantities. 36. Logarithmic scales in engineering. Logarithmic scales are used in various engineering fields, such as electrical engineering and mechanical engineering. 37. Logarithmic scales in computer science. Logarithmic scales are used to analyze algorithms and data structures. 38. Logarithmic scales in statistics. Logarithmic scales are used to analyze statistical data and models. 39. Logarithmic scales in finance. Logarithmic scales are used to analyze financial data, such as stock prices and interest rates. 40. Logarithmic scales in marketing. Logarithmic scales are used to analyze marketing data, such as sales and customer satisfaction. 41. Logarithmic scales in medicine. Logarithmic scales are used to analyze medical data, such as disease incidence and mortality rates. 42. Logarithmic scales in psychology. Logarithmic scales are used to analyze psychological data, such as learning curves and memory retention. 43. Logarithmic scales in sociology. Logarithmic scales are used to analyze sociological data, such as population growth and social mobility. 44. Logarithmic scales in anthropology. Logarithmic scales are used to analyze anthropological data, such as cultural diffusion and technological change. 45. Logarithmic scales in environmental science. Logarithmic scales are used to analyze environmental data, such as pollution levels and biodiversity. 46. Logarithmic scales in political science. Logarithmic scales are used to analyze political data, such as election results and public opinion polls. 47. Logarithmic scales in education. Logarithmic scales are used to analyze educational data, such as student achievement and teacher effectiveness. 48. Logarithmic scales in law. Logarithmic scales are used to analyze legal data, such as crime rates and sentencing patterns. 49. Logarithmic scales in sports. Logarithmic scales are used to analyze sports data, such as player performance and team rankings. 50. Logarithmic scales in architecture. Logarithmic scales are used to analyze architectural data, such as building size and energy consumption. 51. Logarithmic scales in art. Logarithmic scales are used in art to create visually interesting compositions. 52. Logarithmic scales in music. Logarithmic scales are used in music to represent pitch and frequency. 53. Logarithmic scales in photography. Logarithmic scales are used in photography to represent exposure and image brightness. 54. Logarithmic scales in video games. Logarithmic scales are used in video games to represent character attributes and game progression. 55. Logarithmic scales in virtual reality. Logarithmic scales are used in virtual reality to represent distance and scale. 56. Logarithmic scales in augmented reality. Logarithmic scales are used in augmented reality to represent real-world objects and virtual elements. 57. Logarithmic scales in robotics. Logarithmic scales are used in robotics to represent sensor data and control signals. 58. Logarithmic scales in artificial intelligence. Logarithmic scales are used in artificial intelligence to represent neural network activations and learning rates. 59. Logarithmic scales in machine learning. Logarithmic scales are used in machine learning to represent feature importance and model performance. 60. Logarithmic scales in data science. Logarithmic scales are used in data science to represent large datasets and complex relationships.